Here we go. All right, so density and specific gravity. So let's just start in a little bit on this stuff, just basic hydraulics, okay? So that's the first thing we'll look at. Now, in the book, this is chapter 7 of all places. The book is written as kind of an introduction to water math, so to speak, and computations. If you're in the water program, you probably took this class with a class like this with Brian in the fall, right? And you use the exact same book. See, what we're going to do is just continue that and push it further is what we're going to do now, okay? So that's the idea. So we're going to start with density and specific gravity, which is actually chapter 7 of the book, okay? So let's just have a look at just this basic idea in hydraulics, just to kind of get started, okay?
It says chapter 7. Chapter 6 also says density.
Oh, I think it's chapter 6. Yeah, I guess it is chapter 6. My bad. Okay, so page 51. Thanks. Yeah, we're page 51 is where we're at, okay? Okay, let's have a look at density and specific gravity here. You know, when I was a kid, they used to have a joke, you know, one of those jokes that kids tell each other to fool each other. What's heavier, a pound of lead or a pound of feathers, right? I don't know if they told that joke when you were a kid or not, but they did when I was a kid. And, you know, everyone wants to say a pound of lead is heavier, but obviously it's a joke. I mean, they're the same because they're both a pound, right? How you're fooling people on that is people think in terms of density sometimes. Okay, lead has a higher density than feathers does, okay? Or in this case of the book here, styrofoam does. What density does is it takes a given volume, like a cubic foot or a gallon or something like that, and then it has you put the weight of the substance over its volume. And if you divide the weight by the volume, you get the density. Okay, so you know, lead is a very dense substance. Styrofoam is not. Okay, so you kind of think in those terms. The more a given amount of something weighs, the higher its density. Okay, so in the English system, which we still use here in America for whatever reason, I mean, the rest of the world is on the metric system. We're not. We're still in the English system. What we use for density are two common ways of measuring it. We use pounds per cubic foot or pounds per gallon. And a pound is abbreviated LB, which I think comes from some sort of Latin word. I'm not quite sure, but we abbreviate a pound as LB, all right? Now, when we look at water, which is what we're interested in here, temperature and pressure can influence the density, okay? Higher temperature usually leads to lower density. Higher pressure usually leads to a higher density. But what you'll find if you work for a water utility is it's usually easier to pump in the summer because the water's warmer, a little less dense, okay? In the winter, it gets colder and more dense. It's harder to pump. Okay. So the numbers that we'll use for water, and these are right on your formula sheet, are water weighs 62.4 pounds per cubic foot and 8.34 pounds per gallon, okay? And if you're ever walking around and going camping or something in dry country and you're carrying water around with you, you'll figure out how heavy it is. I mean, a gallon is 8.34 pounds, okay? So, you know, you'll figure out that's kind of a lot for a gallon to weigh, all right? All right, so let's say we got 4 cubic feet of a material and it weighs 424 pounds. What's the density of that stuff? If that's the case, just work that out. Good idea to bring a calculator with you here, you know, in the future too. We use them all the time. We just go through stuff in class. I mean, that's what we do. That's how we go over this. got 4 cubic feet of the material. It weighs 424 pounds. We're going to find the density. And take a wild guess. It's something like 106 if you might guess, but I don't know. Is that about right?
Yeah.
Okay. Something like that. Okay. All right. Now, one of the goals here is for you all to learn about hydraulics. The other is to get more comfortable doing calculations and more reliable at it. I'm an engineer, actually. I'm a civil engineer, and we don't like screwing up on calculations. That leads to some bad things happening. People get angry and yell at us. We start losing money and all that kind of stuff. And if you're in water, any of these fields, you really, you got to get this stuff right. If you're doing dosage calculations and you're working for a water utility, man, you better have a good system and think about it that way. What's my system so I don't screw up? Because you don't want to be dosing the chemical wrong when you're making drinking water, right? That falls in the bad category of experiences on the job, right? Okay, so what I do, and I take my time on this. I don't rush it. I don't get lazy. I kind of take my time on this. I keep my units. I write down what I'm doing, and I follow it through. Okay. So what I know is I'm shooting for density, and that's in pounds per cubic foot. Okay, I know that. And sure enough, I got pounds and I got cubic feet. So units are a big deal, okay? And I use them a lot when I'm working, because I just want to be sure I'm doing it the right way. The other thing I'll tell you is I used to tutor in a math lab, kind of like what we got here at OB, and I used to tutor physics, and I didn't know too much about physics, but I knew that units had to work out, and I could solve about 90% of those physics problems just because I knew the units had to work out. So, okay, so that's another thing to know about this stuff. Okay, so what we got here, we're going to put the pounds on the top, and that's 424, because see, it's on the top here. And then I'm going to put the cubic feet on the bottom, right? All right. All right, now what's going to happen here is I'm going to take the numbers and work with them. I'm going to take 424, divide it by 4. I'm going to get 106. And then the units, I kind of think of those like they're algebra variables, like X and Y or something like that. They just kind of come along for the ride, so it's pounds over cubic foot. Okay, so that's how I do that. So that's the density. That's how much that's a cubic foot of that stuff weighs. Let's say that's a liquid, okay? And let's look at what's water. Water is 62.4 pounds per cubic foot, right? Let's say this stuff's a liquid and I pour it in a river. What's it going to do on the water? It's going to sink, yeah, okay, because it's heavier than water, okay? So that's one use of this, We get some indication of how these materials act. Their density will help us get that figured out, okay? All right. So we good with that? How about this one? We got a box, 8 inches by 2 feet by 3 feet. What's the density of this stuff? I got it. Good? Okay. Okay, now you gotta be a little careful on this one, because we got one of those dimensions is in inches. Okay, now inches don't match feet. They when you're doing this stuff, units should match if you want to get a realistic volume. It looks like we're shooting for cubic feet. All right, so I'll do a little conversion there, right? Because I know I got 8 inches, and what I know is that 12 inches is 1 foot. Okay, so just like those algebraic variables, like x's or something, I got one on the top, I got one on the bottom. Inches cancel. divide it by 12, and I'll get feet out of that. And I like to carry 3 significant figures, so that'll be 0.667 feet. So that's the height of this box. Okay. So I wouldn't want to use 8 inches for that. So you probably want to get the volume of the box, okay? To get the volume of the box, we can multiply the 3 dimensions together. Okay, so get the volume of the box. That's what you got to do on this first. Now, if you remember this volume stuff, what you do, you find the area of one of the sides and then multiply that by the depth. So what the area of one of the sides is a length by the width, because that's just a rectangle. And then you multiply that by the depth. So you end up just multiplying the 3 dimensions together. You'll get about 4 cubic feet for that box.
2.96.
Yeah, okay. Just depends on how you round a little bit, but yeah. Yeah, either way, we're not too, I'm not too worried, that'll come up a lot in this class. We just kind of round off, no worries. If you got 3.96 and I got 4, whatever, it's not a problem, okay. Okay, you take the weight. And divide it into the volume. Okay, weight on top, volume on the bottom. And then that'll get you the density, okay? Or at least what we in this country would call density. It's actually not technically correct to call this density, but it's good enough. It's the common usage of the word, and so it's fine. I have a little trouble with my pen there. I'm going to have to get that kind of straightened out, but there we go. So about 75 pounds per cubic foot. We okay with that? Okay, get the volume first, then divide the weight into the volume. Okay. And this is probably the most basic characteristic of water. So this is kind of where we start, is this idea of density. Okay. So we good? All right, now the other thing I point out here is that I got feet, I got feet, and I got feet. Okay, it shows up 3 times. So when I multiply this stuff together, what's happening there is I take feet times feet times feet. And just like if you took x times x times x, you get x cubed. Feet times feet times feet is cubic feet, okay? Same thing, all right? And, if you're doing construction type stuff, or if you're buying I guess, bark dust or whatever, you buy it by the yard, right? You know, or if you're moving dirt around, you call it out by the cubic yard. Quite often they'll abbreviate that to say the yard, but really what it is, it's a cubic yard. 3 feet by 3 feet by 3 feet. That's a cubic yard, you know. They'll call it a yard, but it's really a cubic yard. All right. All right, so that's density is weight over volume. Now you can go the other way with it too if you want. You can just rearrange that a little bit algebraically. So weight is density times volume, okay? So if you take a density, multiply it by a volume, you'll get the weight of the substance. And that can come in if you want to know, you know, if you got a tank full of water and you want to know what it weighs, how hard it's pushing on the ground and on the footing underneath it, you'll do something like this, see? So you know the density of a substance here is 80 pounds per cubic foot, and we know the volume. Well, we can find out how much that would weigh, all right? So that's kind of running it back, so to speak. We'll just go the other direction with it. So that's a little bit of algebra that we're doing there. We're just rearranging the formula to solve it for weight, okay? So if we got 80 pounds per cubic foot, and then we've got 6 cubic feet. Now, a lot of times I'll put something over 1 because something over 1 is the same thing as, you know, whatever it is. 6 cubic feet over 1 is the same thing as 6 cubic feet. I put the 1 on the bottom. That makes it clear for me how to work with the units. So sometimes I do it that way because it just, it makes it clear to me how to proceed, okay? I kind of go into calculations with the basic assumption that I'm not really good at it, okay? And then what I do, I take all these steps to make sure that I do it right, even though I'm not that good at it. I get all these habits going, so I'm nice and systematic, and I just walk through it, and I don't make these careless errors, okay? And then, you know, if I'm out there and I got a set of plans on the hood of the truck and it starts raining and I got a contractor yelling at me and somebody on the survey crew is having a bad day and all this stuff's going on, I've got all these habits that kind of cover that stuff for me, you know, so I don't get distracted and make errors, okay? So I got cubic feet on the top and I got it on the bottom. See, they cancel, all right? And so you see, I'm just left with pounds there, aren't I? And they're the only unit left on the top, okay? So it's just like algebraic variables. I got 1 on the top, 1 on the bottom. I can cancel them out. And then I take 80 times 6, and that ought to be about 480, I think. Pounds, okay? You all right with that? We're doing okay? I mean, some of you have had this already, some of you not, but you know, we're just trying to walk through it step by step, okay? All right, we're good? All right. All right. How much is this one going to weigh? We know the density of this stuff is 70 pounds per cubic foot. Yeah, you're gonna have to find that volume first, eh? So get used to that. We want to be able to find volumes of tanks. You know, kind of get back to that rounding thing too. I mean, like what's 3.964? You know, if you have to measure that tank, you're gonna go out there with a tape measure. You're not gonna get it perfect anyway. You know, I mean, you know what I'm saying? So that's kind of, I'm just using this as an example, right? I don't think we'll work about a couple of numbers here, because in the real world, working, you know.
Well, sometimes it's easier to whole numbers too.
Yeah, right, yeah. There's all sorts of different situations you can get in. But, you know, if you get somebody out there with a tape measure, that may not be exactly 2 feet, that may not be exactly 4, it may not be exactly 5, but you just call it that because you got to measure it and call it something. So, you know, so I just kind of keep that in the back of my mind when I'm thinking about rounding numbers. You know, I work with them and I carry significant figures. I do all the stuff, but all the same, in the back of my mind, I kind of keep in mind what, you know, what the realistic values is I've got here. Okay. So get the volume first, then you can find the weight. 2,800 or something like that, I think. Is it 40? Something like 2,800, something like that. Okay, all right. Okay. All right. So a little bit there on density. Okay, weight over volume. You can also find weight by taking density times volume. You can do it either way. Okay, depending on what you want. Okay. All right. So. You got any questions on any of that? Okay. So let's see. I don't think we do. Okay. Now, see, I'm just following right along in the book. All this stuff is right in that book. So you just, you know, get the book, put it in a binder, just follow along. We'll do a lot of this in class because I think you learn better doing it yourself than listening to me talking about it. And that's the method. That's really all there is to it. Bring a calculator with you, bring the book and a pencil, and you know, we'll just walk through stuff. We just start at this basic level. We'll just start walking through. It'll be the deal. Okay. Now I'll get this recording posted in Moodle, so there'll be a link there. And then next time I'll figure out what the name of my YouTube channel is. If you just want to go there, you can subscribe and do it that way too. But you know, all these things will be posted. So if you're out for a day and you need to catch up, you just watch the YouTube video. If you want to review, you know, that they'll be there too. Okay. All right. Now, no homework today, but maybe about once a week or so, I'll give you homework today. Okay. All right. So we good? Okay. But I think that's enough for one day. So we'll call it good.